on? What's wrong? You look so sick. Are you okay?
I'm fine. I feel I'm fine.
Oh my gosh, you're so burning right now.
It seems like you have a fever. You have a fever.
Yeah, I do.
It sounds like you need a carrot soup.
Yeah, I need it right now.
Okay, lay down. Lay down.
You're so pretty when you sing. Please stay warm, okay?
In this video, we want to talk to you about decreasing cooking time for carrots. The experiment will vary the surface area of carrot by cutting smaller pieces in boiling water. We'll measure the time it takes for the carrot to cook and soften. We'll be using Fick's first law of diffusion to prove to you that the surface area does influence the cooking time. To use the Fick's law of diffusion, we have to make a few assumptions. The first we considered was that water is boiling at 100 degrees Celsius with constant density, and the temperature change due to the seasoning is not considered. Even though the actual shape of the carrot would not be a perfect cylindrical shape, we use the average length and diameter to calculate the surface area for the cylinder.
Ta-da!
And then,
For the second soup, we're gonna add our medium-sized carrots.
add those very small sized carrots to the small pot here. Follow. That's how you put them in the water without getting burnt. Delicious!
It smells so good. So here, Saran is adding a little more flavor to the soup because we don't want to just give our roommate carrots.
Yeah, so we added some tomatoes, you know, and some pepper for the taste and ice. Because she's sick, she's coughing, and yeah, you know.
We want her to get better.
Go on, I don't want you to die.
We need you.
We need you.
We need to.
Now we are checking the softness of the carrot. So the smallest one seems to be already done. So we're just gonna turn it off, which is, oh my gosh, this one, perfect. The second one, which is like the middle size carrot, it's still a little bit hard in the middle. So we're gonna wait a little longer, like 1 minute more or 2 minutes. And the bigger sizes, which are struggling, yeah, it's a little bit harder in the middle, like you can see. So we're gonna wait a little bit longer for that.
So here are the dimensions of the average carrot, which were used to calculate the total surface area for the mass transfer. As is shown in the last column of the table, with varying size and thus its total surface area for the carrot, it was able to confirm that the cooking time for the carrot varies with the dimensions. We used the hardness test to determine if the carrot was fully cooked. If the carrot was completely cooked, then we would have no trouble piercing it thoroughly with a knife. And here are the results. In the left-hand side of the graph, we have our experimental data, and we can see that as the total surface area of the carrot increases, the cooking time required to cook the carrots decreases. Fick's first law is used to explain why this chopping the carrot method works. By increasing the area of the carrot-water interface, a greater number of molecules can actually diffuse into the stock per unit time, and the larger interface and smaller dies effectively increase the mass transfer, which means that the stock achieves the same level of the flavor within a shorter period of time.
So now that the carrot soup is ready, I'm gonna try it first. Saran, I think it needs like a little more salt or seasoning or something. What do you think?
Did you say seasoning? Let me add some seasoning salt. Okay, keep going. Perfect.
Oh, okay, let me try it now.
Do you like it better?
It tastes much better now. I think it's ready.
Gwen, where are you?
Go on, your soup's ready.
Oh my gosh, guys!
I want you to try it. Me and Saran made it from scratch.
Yeah, please try it.
Just try it.
Oh.
How does it taste?
I feel like my fever's already gone.
Oh my god, I can't believe that. It's true.
Oh my god.
Look at that.
Actually eating it.
Me and Saran are excellent chefs.
Okay, honestly, it's mostly Saran. You almost burnt yourself. Engineers do it with our future engineers.